Welcome to Deep Dive Learning by HaleForm Episode 1.
Great to be here.
And for this first deep dive, you sent over some really detailed hexagon documentation. It's all about Intergraph Smart 3D Global Workshare, specifically with Oracle databases.
That's right. And since HaleForm Technology Solutions really knows their stuff in this area, we'll be weaving in some insights about their capabilities as we go.
Sounds good. So our mission today basically is to give you, the listener, a clear picture of what Global Workshare actually is, why it's useful, the benefits, and maybe most importantly, what you need to think about if you're considering it.
Yeah, the key considerations. It's powerful, but it's not plug and play.
Right. Okay, let's dive in then. What exactly is this Global Workshare thing?
Okay, so Global Workshare Configuration, or GWC as you'll see it called, it's essentially a system for companies that have teams working in different physical locations. Think big EPCs, owner-operators, maybe even different companies, all needing to collaborate on the same 3D model.
So distributed teams working on one project.
Exactly. The core idea is that everyone shares all the data within a single model structure, even if they're miles apart. All the changes, no matter where they're made, they all flow back and get merged into one central database structure.
Okay, so it feels like everyone's working locally, even if they're not.
That's the goal. It's designed to feel as if all the work was done right there at the main site, accessing the same live model.
That sounds pretty powerful for big, complex jobs. How does it manage the geographical separation? I see this term locations popping up a lot.
Yeah, locations are fundamental. They're basically the distinct geographical hubs that are part of the workshare. And there are two main types you need to know about: the host location and satellite location.
Host and satellite. Okay.
The host location, that's where the original master databases live, usually on a local network, a LAN. This gets set up automatically when you first create the project databases using the database wizard. It defines the project's core identity, its naming rules, the main server.
Right, the command center, so to speak.
Pretty much. And then you have the satellite locations. These are replicated databases, also on LANs, but out at the remote sites.
Okay, so copies of the host data.
Replicated copies, yeah. But unlike the host, these are created manually. An administrator connected to the host uses the project management tools. There's a specific command, database new location, to set them up. You need admin rights on the site database for that.
And these satellites can be linked to specific teams or permissions.
Exactly. They can be associated with permission groups, controlling who sees and does what, and even linked to specific models within the whole Workshare setup.
Makes sense.
And, this setup, managing hosts and satellites, it requires expertise. It's worth mentioning here that HaleForm Technology Solutions has a really strong team of smart 3D administrators who are experts at handling this stuff, both host and satellite sides of GWC.
Good to know. So if someone needs help setting this up or managing it.
Yeah, they should definitely reach out to HaleForm. Their contact is business.development@haleform.com.
Okay, good tip. So we have the host as the origin, satellites as the remote hubs. How does the actual data sharing, the synchronization, happen between them?
Right, so it relies heavily on database replication, but it's not all the same. Different types of data get handled differently for what's called reference data. That's stuff like your catalogs, the catalog structure, site configurations, schemas.
The foundational stuff.
Exactly, the building blocks. That data uses one-way replication. It flows from the host to the satellites. So the remote sites get read-only copies of this reference information.
Read-only, so they can't change catalogs locally.
Correct, and this is critical. Any changes to that reference data or managing the permission groups that control access must happen at the host location.
Ah, okay. Central control for consistency.
Precisely. It prevents conflicts and keeps everyone working from the same playbook. That's key for data integrity in these multi-site projects.
So the host is the single source of truth for the project fundamentals. What about the actual 3D model data? The stuff designers are changing every day.
Okay, that's where it gets more dynamic. The model database itself uses two-way replication between the host and each satellite.
Two-way. So changes flow back and forth?
Yep. Any change made at a satellite, adding equipment, routing pipe, changing steel, gets sent back to the host server. The host then acts like a hub, basically redistributing those updates to all the other satellites in the GWC.
So everyone eventually sees everyone else's changes.
That's the idea. This back and forth ensures everyone, no matter where they are, is working with the latest, most complete version of the model. Any work done anywhere should end up reflected everywhere.
Wow, okay. That sounds like potentially a lot of data flying around. What about keeping things stable? Performance, backups.
Absolutely critical points. Once GWC is set up, you absolutely need a solid backup strategy. The recommendation is to use the Smart 3D project management backup tools regularly. And, importantly, create backup sets from all locations, host, and every satellite.
Like a distributed safety net.
Exactly. If something goes wrong, data corruption, server issue at any site, you can restore from any of those backups within the workshare and then get replication going again.
That's crucial.
And one more thing here, the documentation warns that setting up GWC in a really complex integrated IT environment can get tricky. If that's your situation, they strongly recommend contacting Hexagon support for guidance. Don't try to wing it.
Sound advice. Okay, we've got the data flow. What about the tech underneath? The network, the systems? What do you actually need for this to work smoothly?
Network is huge, obviously. For big projects, the docs mention a minimum of a fractional T1 connection that's around 256 to 384 kilobits per second.
That doesn't sound like a lot by today's standards.
It doesn't, but here's the catch. Replication speed is mostly bound by latency, not bandwidth. Latency is the delay, the time it takes data packets to travel back and forth.
So it's more about the ping time than the pipe size.
Pretty much, yeah. More bandwidth helps, especially during the initial setup when you're moving lots of data. But just throwing more bandwidth at it won't necessarily speed up the day-to-day small changes significantly if your latency is high. Low delay is key.
Okay, low latency between the user's machine and their local database server is what you need for good responsiveness.
Exactly. Minimize that delay. Now, the docs also mention virtualization, running your Oracle databases on VMs.
Is that doable?
Technically, yes, it's possible, but it comes with a big flashing warning sign. You have to test it thoroughly. Make absolutely sure your virtual environment can handle the production workload without creating bottlenecks that mess up your project schedule. I/O performance is often the worry there.
So test if you go virtual.
Definitely. And, speaking of getting the work done within these environments, it's probably a good time to mention HaleForm Technology Solutions again. They don't just handle the admin side. They also have teams of skilled, multidisciplined smart 3D modelers ready to jump in and help clients actually build the models within Smart 3D.
So they cover both the setup and the actual modeling work.
Yep, full service.
Okay, so you've got the infrastructure sorted, hopefully low latency. But I imagine in a distributed setup like this, you can't just do anything from anywhere, right?
Yeah.
Are there limits on tasks depending on if you're at the host or a satellite?
That's a very sharp point. Yes, there are definitely limitations. Not all Smart 3D tasks are equal in a GWC world. We can kind of split them into administrative tasks and, the actual modeling environment tasks.
Okay, let's start with admin stuff. What's host only?
Several really core admin functions can only be done at the host. Things like creating new permission groups or the folders they live in, adding or changing users in those groups, assigning those permission groups to different locations.
So managing who can do what, basically.
Right. Also, adding new custom properties to object types in the model, creating the actual location objects themselves that define the sites, and running the database integrity command to check for issues. All host only.
That makes sense, keeping central control.
Yeah.
What about other admin commands? I see some listed as conditional.
Good catch. Yeah, commands like duplicate model for workshare, which you use to set up the satellites initially, and bulk load to the catalog database for importing lots of catalog data. They can be run at the host, but they're marked conditional. Meaning there are probably specific steps or things you need to be aware of, potential impacts within the GWC context before you just fire them off. You need to read the fine print, essentially.
Gotcha. Any admin tasks doable at both?
A couple. Regenerate the reports database can be run at both host and satellite. Same for synchronize model with catalog command, which updates the model based on catalog changes. But running that sync command at a satellite has specific consequences for things like to-do lists and how views get updated. So again, conditional awareness needed.
Okay. And changing shared content paths.
Yes. If you need to change the shared content path for the catalog database where shared files live, you can only do that for the local catalog database at a satellite. You can't change the host's path from a satellite, for instance.
Okay, that's quite a bit on the admin side. What about when you're actually in the model doing design work? Restrictions there?
Yeah, similar pattern. Viewing reference data in the catalog task, that's fine. At both host and satellites, users need to see the parts list, right?
Sure.
But most other commands within the main Smart 3D modeling tasks, excluding project management and just viewing the catalog, are listed as conditional at both host and satellite.
Conditional again, so proceed with caution everywhere.
Kind of. It highlights that you need to understand the workflow. But critically, anything involving actually creating, modifying, or deleting the core catalog data itself. That's strictly host-only territory.
Okay, catalog management is centralized. What about placing pipes, equipment, managing drawings?
Those kinds of tasks, working with objects and systems, managing the hierarchy in drawings and reports, using view styles, filters, transferring selections, working with location-specific stuff, are all listed as conditional at both locations.
So it really emphasizes planning where certain types of work should happen.
Absolutely. Understanding the intended workflow and the permissions is key. And speaking of catalogs, this is probably a good spot to mention HaleForm's catalog customization team. They're pros at handling piping spec customization, but also electrical, HVAC, equipment, structure, basically the full range.
Another resource then. Same contact, business.development@haleform.com.
That's the one. They can handle all those catalog needs.
Okay, so plan your work, know the limitations. What about really big operations, like deleting thousands of objects or importing huge data sets? Any special advice for doing large transactions in GWC?
Definitely. Large transactions need a bit more care in a GWC setup. The general advice is, first, try to do them during off-peak hours. Less load on the system, less impact on other users waiting for replication.
Makes sense. Avoid prime time.
Second, if possible, break large operations into smaller chunks. Say you need to delete a ton of imported Tekla structural data. Instead of selecting everything at once, maybe do it in smaller batches. It's often smoother for replication.
Less likely to choke the system.
Exactly. Same goes for deleting lots of drawings or copying or moving large numbers of model objects. Smaller bytes are generally better.
What kind of things typically count as large transactions here?
Several things can generate a lot of data chat. Using model data res features to copy big chunks of a model for sure. Running database integrity checks, which, remember, has that specific host-then-satellite cleanup workflow. General database maintenance, like clearing out old or obsolete objects.
Okay.
Deleting large amounts of existing Tekla data before an import is another one. Deleting lots of drawings, or just bulk delete copy move operations on model objects. All those can create significant replication load.
So think ahead, plan it out, maybe do it overnight or in pieces. Got it. Now, I see the docs talk about combining Global Workshare with Smart Plant Foundation, SPF. How does that work? Is it common?
Yeah, that's a pretty common scenario, actually, and often very useful. You can definitely use GWC alongside SPF. It lets you leverage that central SPF repository for documents and data, even with your teams spread out via GWC.
So you can publish documents to SPF from anywhere.
Pretty much. The software supports publishing to SPF from all access levels in Smart 3D, whether you have write access or just read-only in that part of the model. You can publish documents linked to permission groups owned by a satellite, for example.
Are there any catches?
A couple of things to be aware of. Actions in SPF, like revise and update, still need you to have write access in SPF. And sometimes, when publishing from a satellite, documents that are actually read-only might look new to SPF because the local timestamp information might not be fully up-to-date via replication yet.
Ah, okay, a potential sync quirk.
Yeah.
What about best practices for making SPF and GWC play nicely together?
Two key recommendations stand out. First, try to do all your data retrieval from SPF from just one designated GWC location, either the host or a specific satellite. And ideally, make the permission group used for that retrieval only available at that single location.
Why is that?
It helps avoid potential object ownership conflicts that can pop up if multiple sites are pulling data related to the same objects via different permission groups. GWC will still replicate the retrieved objects everywhere, but this helps manage the initial ownership.
Okay, centralize the pull from SPF. What's the second thing?
The initial registration of the Smart 3D model with the SPF site, that must be done from the GWC host location.
Host does the registration. Got it.
And, thinking about integration and making things work smoothly, HaleForm also has skilled programmers. They can handle various Smart 3D customizations, things like hangers and supports, custom 3D symbols, name rules, even rule checker services.
So custom development too.
Yep. They cover a lot of ground. Same contact, business.development@haleform.com for those kinds of needs.
Useful to know.
Okay.
Valuable pointers on SPF integration. Next up in the overview is something about archive logs. Deleting them carefully sounds important.
Extremely important. Getting archive log deletion wrong in an Oracle GWC environment can be disastrous. You could lose data, destabilize the whole workshare. It's serious.
So what's the guidance?
The docs point directly to the Oracle Golden Gate Administrator's Guide. There's a specific section on purging archive logs that details exactly which logs are safe to delete and how to do it properly based on your Golden Gate setup. Don't guess.
Okay, follow the Golden Gate Bible.
Absolutely. And even more critically, before you delete any archive logs, you must verify that your regular database backups, including log file backups, are working correctly and are reliable.
Double check the safety net first.
Exactly. You don't want to delete logs needed for recovery and then find out your backups are bad. That's a nightmare scenario.
Definitely sounds like something to treat with extreme caution. Okay, solid advice. Now, the documentation seems to shift gears a bit here, moving into more of a what do you want to do section. Lots of setup and maintenance tasks listed. Hub and spoke setup, the whole Oracle GWC setup process, monitoring, permissions. Maybe we should tackle the big one. Actually setting up an Oracle Global Workshare. Looks like quite a process.
It really is. It's a multi-stage process, and you need to be meticulous. The core technology driving the replication, as we've touched on, is Oracle Golden Gate. That's what handles capturing changes at the host, sending them to the satellites, and applying them. And vice versa for model changes made at the satellites going back to the host.
Right. Golden Gate is the engine.
Yep. And first key point. Oracle GWC requires the Oracle database to be running on Windows. No Linux support mentioned here. And I have to repeat the warning about archive logs. Never delete them unless you are absolutely certain following the Golden Gate guidelines. It can break the Golden Gate extract processes, and fixing that can be incredibly difficult.
So Windows only, and be paranoid about archive logs. What else is crucial from the outset?
Consistent monitoring. Daily checks of Oracle Golden Gate are essential to make sure data is flowing, processes are healthy. Catching and fixing issues early is vital for keeping the Workshare reliable.
Okay, so before we even think about smart 3D models, the underlying Oracle setup needs serious attention. What's involved in that initial prep?
Several key things you need to verify or configure on all the Oracle servers involved, host and potential satellites. First, supplemental lighting must be enabled.
Supplemental logging.
Yeah, it tells Oracle to write extra info into its redo logs, which Golden Gate needs to capture changes accurately. There's a SQL query to check if it's on. If not, you have to shut down the instance, mount it, run some alter database commands to add the logging, and then open it back up.
Okay, sounds like DBA territory. What else?
Archivilog mode. All the databases need to be running in Archivilog mode. This means Oracle archives its redo logs, which is what Golden Gate uses as its source for changes. You can check this using the archive log list command in SQL+. If it's not on, again, you need to alter the database, which usually needs admin rights.
So enable extra logging and make sure logs are being archived. Got it. Any other specific Oracle settings needed?
Yes, a few more parameters need checking. There's an Oracle instance parameter called Enable Golden Gate Replication that has to be explicitly set to true. Use alter system, then restart the instance.
Okay, enable Golden Gate Replication true.
Then there's the Oracle Streams pool size. When Smart 3D uses Golden Gate in integrated capture mode, the Streams pool handles the workload from the extract processes capturing changes. The docs suggest a starting size, like 1280 megabytes, but also give a formula based on your number of locations and databases, plus maybe 25% headroom, too small, and performance tanks.
So size the streams pool carefully.
Right. And finally, it's recommended to set the undor tension parameter to at least 800-6400 seconds. That's 24 hours. This helps Golden Gate's change capture work optimally. Again, alter system and a restart are needed for that.
Wow, okay. Definitely not just clicking next on an installer. You need deep Oracle config. What about Golden Gate itself? How does that get installed and set up?
Golden Gate software needs to be installed on the same server as the Oracle database it's working with. Best practice is to install it on a separate physical disk or RAID array from your Oracle database files, just to minimize I/O contention. Exactly. You'll need server admin rights for the install. Run the installer, pick a location, decide if you want the Golden Gate Manager service to start automatically. This manager service is key. It controls the other Golden Gate processes. You'll also point it to your Oracle installation and give it a TCP/IP port. The default is 7809.
Port 7809.
Okay. If you happen to run multiple Golden Gate instances on one machine, which is rare, they'd each need a unique port. After install, a crucial first step is creating a dedicated Oracle Golden Gate Administrator account in the Oracle database.
A special user for Golden Gate.
Yes, and definitely don't use SYS or system. You need a specific user, usually called GGAdmin, with specific privileges. Smart 3D typically provides a simple script for this in the shared content folder. Use that script to create the same GWC user with the same password, usually manager by default, on all the Oracle servers, hosts, and satellites for consistency.
Okay, install Golden Gate, create the DGMN user. Then there's this Smart 3D Golden Gate user alias. What's that about?
Right, the alias. It's basically a secure way for Golden Gate to handle database credentials. Instead of putting usernames and passwords directly in config files, which isn't secure, you create this alias.
How does it work?
You'd first create another dedicated Oracle user, maybe called Sridig users, granted the necessary rights. Then, using the Golden Gate command line tool, GWC, you add the username and password for Sridig user into Golden Gate's secure credentials store. You link these stored credentials to an alias name, typically Sridig Golden Gate.
And Golden Gate uses the alias.
Exactly. The Golden Gate config files just refer to the alias Sridig Golden Gate, and Golden Gate knows to look up the stored credentials for Sridig users to connect to Oracle. It's much more secure. You should also test it using Gizro. Try logging in with the alias to make sure it's set up right.
Smart. Security first.
Ah.
Okay, Oracle's prepped, Golden Gate's installed, users are set up. What about the network side? Firewalls, connectivity?
Absolutely need firewall rules. Stateful firewalls are recommended. You need to open up the TCP port for the Golden Gate Manager service, that default 7809 we mentioned.
Open port 7809.
And you need to add the actual Golden Gate executable files, mgr.exe, server.exe, ggsci.exe, replicate.exe, extract.exe found in the Golden Gate install directory as trusted exceptions in the Windows firewall on every GWC server.
Okay, allow the programs through too.
Plus, and this trips people up sometimes, all the Oracle database instances involved in the GWC need to be properly registered on the Smart 3D administrative machine. That's the workstation where you'll run commands like duplicate model or consolidate. These commands need to connect to all the databases, so your Oracle Net Services configuration, like the TNS names .raw file, needs to be set up correctly on that admin machine.
Right, the admin workstation needs to know how to find all the databases. Okay, lots of groundwork. Now, finally, what are the steps inside Smart 3D to actually kick off the Oracle Global Workshare setup for a project?
Okay, switching hats to the Smart 3D admin now. First step is defining the locations in project management. Go to Database New Location. Give each site a unique name. Link it to the server where its replicated database will live. You can also adjust the name role ID here, which helps track object creation origins. Remember, you can only create new locations when connected to the host project.
Define the players first. Then
the big step. Duplicate the model for Workshare. Select your model in Project Management, then go Tools Duplicate Model for Workshare Command. A dialog pops up. Here you select which satellite locations you want to include.
just the ones you're setting up now.
Exactly. Since it's Oracle, it'll prompt you for that GGA, BMI, and username and password we created earlier. This duplication process then generates a whole bunch of Golden Gate replication scripts and bash files, specifically tailored for your setup.
Smart 3D builds the scripts. That's handy.
It is. But critically, before you run that duplicate command, make a full backup of your current non-replicated Smart 3D databases. Absolutely essential. And also, make sure no one is doing any modeling work on the host or any potential satellite databases while this duplication is running. Lock it down.
Backup first, no users working.
Got it.
So the command finishes, and I've got these scripts. Where do they go? What do I do with them?
Good question. They'll typically land in your local temporary folder on the machine where you ran the duplicate command. They'll be organized into subfolders, one for each server-involved host and each satellite you selected.
Okay, server-specific folders.
Yep. You need to take the contents of each server's folder and copy them into the root directory of the Golden Gate installation folder on that specific server. So host scripts go to the host's Golden Gate folder, satellite A scripts go to satellite A's Golden Gate folder, and so on.
Copy them across the network to the right place. What if files already exist?
Generally, you should let it overwrite. The newly generated scripts have the correct configuration for the GWC you just defined. And, pro tip, make a separate backup copy of these generated script folders somewhere safe. Temp folders can get wiped automatically.
Good idea. Okay, scripts are copied to all the right Golden Gate folders. What's next? Do I just run them? Is there an order?
Yes, there's a specific sequence. The duplicate command generates different types of scripts. The first ones you typically run are the pre-backup scripts. Their file names usually look something like pre-backup instance name cited a deblocation id.bat.
Pre-backup scripts first. What do they do?
Their main job is to create the initial Golden Gate objects and configurations needed for replication to start, including setting up the manager service on each server. You need to run these pre-backup scripts on the host server and all the satellite servers. Log in with OS admin rights.
How do I run them?
Best way is often to open a command prompt as administrator, cd to the Golden Gate install directory on that server, and then run the .bat file. It's also smart to redirect the output to a log file like pre-backup-my-site-a.bat, pre-backup-my-site-a.log. Makes it way easier to check for errors later.
Log the output. Good tip. After pre-backup.
After running pre-backup successfully everywhere, you'll probably need to make a couple of initial tweaks to the Golden Gate parameter file, specifically mgr.prm for the manager, and maybe the globals file. The docs usually guide this. After editing, you need to restart the Golden Gate Manager service, usually named GGS MGRS 3D, in Smart 3D setups on the host and all satellites so it picks up the changes.
Okay, pre-backup, tweak params, restart manager. What's the next phase?
Right, after pre-backup is done and the manager service is happy, the next really critical step is to go back into Smart 3D project management on the host and create a full backup of your host databases.
A backup after pre-backup.
Yes. This backup becomes the synchronized starting point, the initial copy of the project data that you'll then transfer to each satellite and restore there. Make sure this backup includes a copy of your shared content folder and any other reference data. Compressing the backup helps speed up the transfer.
Okay, so create the master backup set.
Yep. While that backup is being made and transferred, users can usually start working on the host again because the basic replication plumbing is now partly in place. Once you get those backup files copied over to each satellite server, you need to restore them.
Restore on the satellites.
How? For the site and site schema databases, you typically use the Smart 3D database wizard. For the catalog schema, and model databases, you use the tools restore command in project management. Now here's a crucial detail. When restoring the site database on a satellite, make absolutely sure the site database workshare location field in the wizard is set to the correct name of that satellite location you're setting up. Very important.
Set the workshare location during site restore.
Got it.
After restoring everything on a satellite.
After all databases are restored on a satellite, you run the post-restore scripts. They follow a similar naming pattern, like post-restore instance name-cited deeplocation ID.bat. Run these from the Golden Gate install folder on both the hosts and all the satellites. These scripts finalize the setup of the Golden Gate replication processes that handle the ongoing sync.
Post-restore scripts finish the Golden Gate setup. Anything else?
One last thing. The reports and report schema databases aren't usually replicated by Golden Gate for performance reasons, so you need to regenerate these locally on each satellite using the regener reports database command in project management. And make sure the reports databases on each server have unique names.
Regenerate reports locally. Phew. That's quite a sequence. Pre-backup, backup host, restore satellites carefully, post-restore, regenerate reports. It sounds like you need a checklist.
A checklist is a very good idea. It requires precision. Now, the docs also mention installing something called the Duplication Synchronization Service, or DUGES. What's that about?
DUGES. What does it do?
DUGES is another important piece. It works alongside Golden Gate replication to help maintain data consistency and integrity in the Smart 3D model within GWC. Think of it as an extra layer of protection against certain types of data inconsistencies.
Like what kind of inconsistencies?
Things like dangling relationships between objects or orphaned to-do list entries. These issues can sometimes pop up more easily in a busy GWC environment with lots of concurrent updates from different locations. DSS helps prevent or clean those up.
Okay, so it's like a data integrity watchdog. Where does it run?
You need to install and configure the DUGES service on the host and on each satellite server. Installation is usually running an executable from the command line with admin rights to register the service. Then you configure its properties in the Windows Services console, set a user account for it to run under, set its startup type to automatic.
And link it to the model.
Yes. Back in Smart 3D Project Management on the host, you go into the Model Properties Databases tab. There you associate the model with the specific computer where DUS is running for the host and for each satellite. DUSS logs its activity and any issues, usually to the system temp folder, which is helpful for monitoring.
Okay, so DUSS is another service to install and manage everywhere for better data health. Now, what if you already have a GWC setup running and you need to add a new satellite location later? Is that a huge ordeal?
Adding a new satellite to an existing Oracle GWC is definitely possible, and it's generally designed to be less disruptive than the initial full setup. The new server needs the same Oracle and Golden Gate prep, of course, supplemental logging, archive-log, GG install.
Okay, prep the new server first.
Then connect to the host in project management, create the new location object, database new location. After that, you run the duplicate model for Workshare command again, but this time you select only the newly created satellite location.
Just duplicate to the new one.
Right. This generates a new, smaller set of Golden Gate scripts specifically for adding this one satellite. You copy those scripts to the host and the new satellite, run the pre-backup scripts on both. Then you need a fresh backup of the model from the host.
Back up the host again?
Yep. Transfer that back up to the new satellite, restore it there, remembering to set the correct Workshare location during the site restore, then run the post-restore scripts on the host and the new satellite. Finally, regenerate the reports databases on the new satellite.
So similar steps, but targeted at the new site.
Exactly. And then monitor Golden Gate closely to make sure data starts flowing to at from the new satellite correctly. The nice part is, users on the existing satellites usually don't need to stop working while you're adding a new one.
That's a big plus.
Yeah.
Flexibility to grow. Okay, so you've got it all set up, maybe added a few sites. How do you keep tabs on it? How do you monitor the replication to make sure everything's actually working day to day?
Constant monitoring is non-negotiable for a healthy GWC. Since Golden Gate is the engine, this often falls to the DBAs. They can use various tools, simple SQL scripts, basic reports, or more advanced Golden Gate-specific monitoring utilities. The key is catching problems early.
What are the basic checks?
First, make sure the Oracle Golden Gate Manager Windows service, often GGS MGRS3D, is running happily and set to start automatically, maybe with a delayed start. Check it in Windows services or use the info mgr command in GShy, the Golden Gate command line.
Check the main service then.
Then you need to regularly check the actual Golden Gate processes. Extract, data pump, and replicat, are they all running? On the host, you'll usually see multiple extracts and pumps, often related to the number of databases and satellites, and one or more replicats applying changes from satellites.
How do you check those?
Use the status command in GShy. It lists all running Golden Gate processes. If you see any crucial ones stopped, their names usually end in E for extract, P for pump, R for replicate, you can try starting them with start process name or start to attempt starting all stopped ones. Regularly checking process status and their log files is essential.
Okay, monitor the service and the individual EPR processes via GShy. Got it. Now, let's shift to how people actually use this. How do permission groups in Smart 3D control who can do what across all these different locations?
Permission groups are absolutely central to managing access in GWC. They control both read and write permissions for different parts of the model across the host and all the satellites. You manage them from project management, but only at the host location.
Most admin sets up the groups and assigns them.
Exactly. You create groups, assign them to specific satellite locations, and grant different access levels read-only or read-write to various model areas or data types. The general best practice is to try and ensure only one location has write access to a specific object at any time to minimize conflicts.
Makes sense. One writer at a time.
Although system-level objects sometimes have slightly different rules, like someone with write access to a systems group might be able to add child objects even if the group is owned by another location, though changing the parent system's properties might still require being at the owning location. It gets nuanced.
So they are exceptions. How do users know which groups apply to them?
When a user logs in at a specific location, they typically only see the permission groups assigned to their location. But you can change the ownership of a group from one location to another using project management on the host. And users can use the transfer command on object properties to move selected objects into a group owned by a different location if needed.
Okay, so groups control access locally, but there's flexibility to transfer ownership or objects. Now, the docs mention routing and IFC permissions specifically. What are those about?
Right. Routing often comes up with things like piping. If you have multiple users in different permission groups working on connected segments of the same pipe run, Smart 3D uses something called intermediate end features, or IEFs.
IEFs?
Yeah, they act like logical connection points between segments owned by different permission groups. It allows users with the right permissions to work on their piece without messing up the right access of someone working on the next piece in a different group. Permission group assignment depends on whether a user created the object, it gets their active group, or the software generated it, it follows internal rules. Modifying higher-level systems often requires write access to both the subsystems group and its parent systems group. It's all managed from the host.
Okay, IES handle connected workflows across groups. What about IFC permissions? Interference checking.
Correct. In GWC, you can give users at satellite locations specific write permissions just for certain properties related to interference check results, typically the required action and notes fields.
So satellites can manage their own clashes.
Exactly. The host admin configures this in project management. Granting these specific IFC write permissions lets satellite users manage and respond to the interferences they're responsible for. But to get these rights, the satellite user needs to be a valid model user locally and have write permission to the relevant IFC permission group as defined back on the host. It's still centrally managed overall.
Very granular control. Okay, so permissions handle access. What happens when the catalog, the library of parts, gets updated back at the host? How do those changes get pushed out so everyone's using the latest components?
Good question. While many routine catalog changes at the host replicate automatically via Golden Gate, there's a specific workflow needed if you do a bulk load of new catalog data into the host database.
A bulk load needs special handling.
Yes, to make sure the satellites properly integrate those new additions. It's a coordinated process between host and satellites. First, at the host, after the bulk load finishes, you select the host model in project management and run the synchronize model with catalog command. Make sure the options mark out of date, update out of date, and regenerate views are all checked. Then, also on the host, regenerate the reports database.
Okay, sync and regen reports on host. Then what?
Then, on each satellite, after Golden Gate has replicated the catalog changes, the first step is to run the View Generator utility. It's usually in the main Smart 3D install folder, pointed at the local catalog database and catalog schema.
Run View Generator locally on satellites.
After that finishes, open project management on the satellite, connect to the project, and run synchronize model with catalog again. But this time, on the satellite, only check update out of date and regenerate views.
Different options on the satellite sync.
Right. And finally, just like on the host, regenerate the reports database locally on each satellite too. This whole dance ensures the bulk-loaded catalog changes are fully reflected in the model and views everywhere, and all reports are consistent.
Wow, okay. That's a detailed sync process for bulk catalog updates. Now, what if companies collaborating via GWC are on totally separate networks? Untrusted domains where Windows authentication doesn't just work across companies. Any advice for that?
Yeah, the docs cover working across untrusted domains. It presents challenges, especially for Oracle GWC, because the standard duplicate and consolidate commands might fail due to database connection issues across those domain boundaries.
So how do you make it work?
There are workarounds. For the initial duplication, you'd likely need to manually add entries for the untrusted satellite database servers into the tnsnames.ora file on the host admin workstation. Oracle Net Services uses this file to find databases. Then, on the satellite server in the untrusted domain, you might have to temporarily change a SQLnet parameter in its skolnet.ora file, specifically authentication services, setting it to none.
Temporarily disable Windows authentication.
Basically, yes, just for the connection needed during duplication. After you create the location object and successfully run duplicate model for Workshare, you'd change that authentication services setting back to its normal value, usually NTS for Windows Native Auth, on the satellite. The rest of the process, copying scripts, restoring backups, proceeds normally.
And for consolidating later.
Similar idea. You run the consolidate command on the host, then execute the generated scripts. You might again need to temporarily adjust Oracle network settings like authentication services on the affected servers to allow the communication needed for consolidation across the untrusted boundary.
So it's doable with careful Oracle network config tweaks. Okay. Now, the tough part. What if things break? What if the host server fails or a satellite server goes down? What are the recovery plans?
Recovery procedures are absolutely vital. If the central host server fails completely, the first thing you must do is stop all work on all satellite servers immediately.
Freeze everything.
Because if the host is down, the satellites will just keep accumulating changes locally that can't be synced anywhere. You risk massive data divergence. So, stop work, then figure out which satellite has the most complete, up-to-date data. Back up that best satellite fully.
Okay, identify the best source, back it up.
Then you need to essentially clean house, remove all the old Smart 3D GWC data from all the servers involved, host, and all satellites, start fresh. Create a new site and site schema on a new or repaired server using the database wizard. Restore the backup you took from the best satellite into this new site, but restore it as a copy so you don't overwrite the clean site DB.
Restore as copy. Then
immediately back up this newly restored model. Then you basically have to reconfigure the global workshare from this recovered model, running duplicate model for workshare again to set up the desired satellites. It's a significant recovery effort.
Wow, yeah. What about just a single satellite failing? Easier.
Generally, yes. If a satellite fails, you typically use the consolidate model from workshare command on the host, specifically targeting the failed satellite location. This generates consolidation scripts. You run those scripts on the host and any other remaining online satellites. If the failed satellite server is still somewhat accessible, you should delete its smart 3D databases to prevent confusion later. Basically, you cleanly remove the failed satellite from the GWC configuration. You could then add a new replacement satellite later if needed.
Remove it via consolidation. What if someone just messes up data? Deletes something by accident?
For accidental data dilution or modification, you can often recover without a full server restore. Use a recent backup of the affected database. Smart 3D has a specific option: Restore Model for selective recovery of model objects. It lets you restore just specific parts of the model from a backup into your live model using copy-paste restore functions within the tool. Very handy for fixing localized mistakes.
Granular recovery. That's good.
But again, none of this works without those regular, reliable backups from all locations we talked about earlier.
Backups, backups, backups. Got it. Okay, the docs also mentioned consolidating Oracle databases. What does that mean? Why would you do it?
Consolidation is essentially the reverse of duplication. It's merging the data from one or more satellite databases back into the central host databases. A full consolidation brings everything back to the host, kind of like how it was before GWC was set up.
So consolidate.
Maybe the distributed collaboration phase of the project is over and you want everything central for final handover or archiving. Or maybe you need to do some project-wide reporting or analysis that's easier with all data in one place temporarily. You can consolidate just one satellite, several, or all of them.
How's it done?
Use the tool's consolidate model from workshare command in project management on the host. You'll need the Golden Gate admin password. It generates consolidation scripts. You copy those to the host and the satellites being consolidated, then execute them. Afterwards, permission groups that belong to the consolidated satellites usually get reassigned back to the host location. And remember, reports databases aren't consolidated, so you'll likely need to regenerate reports on the host afterwards.
And you can use this to just remove a site, too.
Yes, the consolidate command can also be used just to remove a satellite from the GWC without necessarily merging all its data back if that site is simply no longer participating.
Okay, a way to wind down the distributed setup. Finally, there's a command reference section listing key commands: backup, consolidate, duplicate, new location, regenerate reports, restore, synchronize model with catalog. Seems like the core toolkit.
That's exactly right. Those commands, mostly in project management, are the fundamental tools for setting up, managing, maintaining, and eventually consolidating a smart 3D GWC environment. Understanding what each one does and when to use it is crucial for anyone administering or working in GWC.
Well, this has been an incredibly thorough deep dive. We've gone from the basic concept of global workshare all the way through setup, monitoring, management, and recovery for Oracle environments. It's clear it's a really powerful tool for collaboration.
But also one that demands careful planning, a meticulous setup, and ongoing attention to keep it running smoothly.
Absolutely. You, our listeners, should now have a really solid grasp of what GWC involves, the benefits for distributed teams, and the key things to think about, all pulled straight from that hexagon documentation you shared.
Exactly. Hopefully it gives you a framework for thinking about how these ideas of distributed work, data sync, and access control might apply to your own complex projects.
It definitely makes you think, and it sounds like for anyone seriously looking at implementing or needing help managing a smart 3D GWC environment,
HaleForm Technology Solutions is definitely a resource to consider. Their expertise covers the full spectrum we've discussed today, from administration and customization to the actual modeling work itself.
and folks can reach out to them for more info or support.
Yep, the contact is business.development@haleform.com. They're well equipped to help navigate the complexities of smart 3D global workshare.